In this video, we're talking about Euler's form, and it kind of looks like this. It's a way of writing SACE, but instead of writing SACE, you write it in terms of E. Now, the really beautiful thing about Euler's form is it relates trigonometry and exponentials together. So a lot of these properties of SACE that you've seen are actually the index laws in disguise. It's really cool. So let's do this question. E to the I pi is the same as if I wrote SACE of pi, basically, which is going to be cos of pi plus I sine of pi. And then if you want to use your unit circle, cos of pi is -1 and then plus 0i, so it's -1. So the really cool thing there is that e to the I pi equals -1. And often you'll see it with the minus on that bit instead. And that's called kind of like Euler's identity. It's really cool. But the cool thing about it is it kind of looks normal when you see it like that. But remember what the e and pi numbers are. E is like 2.718 and it goes on forever. And it's negative. And then you're going to raise it to the power of square root of -1 times 3.1415 and it goes on forever. And all these horrible, terrible, messy numbers equals 1. It's crazy. So it really shows the beauty between trigonometry and exponentials. And that's what complex numbers allows us to do. So let's calculate another one of these. This is going to be equivalent to SACE of pi over 2. Which is cos of pi over 2 plus I sine of pi over 2. Cos of pi over 2 is going to be 0 plus I times 1, which is going to be I. Cool. All right, next one. 2 to the power of I. Now, I'm going to have to write this 2 with a base of e. So how do I do that? Well, e to the power of log of 2 is another way of writing 2. And I can actually show you. Because e and log are inverses. So if you do an e and you do a log, it will cancel out. So e to the power of a log of 2. There we go, it is 2. Now, that's a fancy way of writing 2. And I'm going to raise it to the power of I. So this becomes e to the power of I log of 2. Which is cos of log of 2 plus I sine of log of 2. And if you want to get really fancy, you can actually work out what that is. Just make sure your calculator is in radians. So you're going to get cos of log of 2 gives you this number, 0.769, plus, and then I sine of log of 2. So sine of log of 2 is going to be 0.639 times I. Beautiful stuff.